Welcome to Vaayusastra Aerospace Future Scientist Meet Chapter 11. So today we have here 5 young, energetic, uh, brilliant minds which are going to change a lot of things in future space industry. We have 5 young talents. We have Adhrith, then we have Darsh Rai, we have Kashikaa, Keerthana, and AD. So that's, you will know who is this AD, and all these 5 young talents, they have various topics starting from International Space Station to supersonic aircrafts, bird attack, how to prevent bird attacks, then about planet Jupiter. Then one person is going to present his own equation. You might have seen Einstein, Newton creating their own theory when they were young. And we have one more youngster who, young scientist who has created his own equation and is going to do his proof of his theory. And that's our AD. So yeah.
Jaku in YouTube is not coming, Jaku.
It's not coming? It's there, it's there.
It has started, Jaku. I'll be able to see it.
Okay, so what I do, I'm going to switch on this unmute option. And first, so we are going to go with this talent. And this talent is studying his grade 6, and from DAV Boys School, Gopalpuram. And he is from this company called Space Eye. Yeah, yes, trust me, believe me, they have their own company. They have CEO, CTO, research scientist, R&D team, whatnot, in grade 6. Okay, and he is going to present on this topic, International Space Station, and the talent's name, Adhrith Narayanan. Adhrit, we are eagerly waiting to listen more about International Space Station. The stage is all yours.
Thank you, Jagu.
Yes.
A second, Jagu, I will present.
Yes.
Yes.
I guess this is Adhrit's second live stream. And he's one of the brightest students from our young researchers group. And we were doing this as a part of our practice for past more than 8-9 months. I think we can start if you're.
Yes, Jagu. So, hi everybody, I am Adhrith Narayanan here going to present about ISS. I am studying in class 6 in DAV. Now today's agenda. An overview on ISS, timeline, design and parts, operations and management, challenges, success stories, and future of ISS. At last, a conclusion and a small quiz. Now, let us see an overview on ISS. So, let us see how it all started. In 1973, before this ISS came into picture, the US launched its first space station successfully. It is called as the Skylab. It could not be reboosted for want of a space shuttle till 1981. This resulted in orbital decay and it got destroyed over Earth's atmosphere in 1979. The Mir is the first modular space station assembled in the orbit by Russia. It was available between 1986 till 2001. In 1984, President Ronald Reagan proposed that US must develop an Earth orbiting space station. In 1988, US invited space agencies of countries like Canada, Europe, Japan to join NASA to develop ISS. US also further invited Russia in 1993 to join towards building ISS. Now, what is ISS? ISS is a modular space station in LEO. It is a multinational collaborative project involving 5 space agencies. It took 10 years and more than 40 missions to assemble ISS in space. It is as big as a 5-bedroom house and stretched to a size of a huge football field. Its weight is 460 tons. It is always permanently manned. It orbits at the orbit which is 250 miles above Earth in a period of 90 minutes. So far, 244 astronauts, cosmonauts, and space tourists from 19 different nations have visited this ISS. The total cost so far is about $150 billion. Now let us see the timeline of ISS. I am going to give some milestones. In November 1998, the first segment of ISS, which is also called as Zarya, was launched on the Russian Proton rocket. 1 month later, in December, the Unity, which is the first US-built component of the ISS, was launched. In November 2000, the first crew went to reside on this station. In February 2001, the US lab module, which is known as Destiny, was added to ISS. It is a primary research laboratory for US payloads. In October 2007, Harmony module, also known as Node 2, is the utility hub of the ISS. It mainly connects the lab modules of US, Europe, and Japan, as well as providing electrical power. In February 2008, Columbus, which is a European lab module, was added to ISS. 1 month later, in March, the Japanese lab module was also added. The Japanese module's name is called as Kibo. In November 2010, ISS celebrated its 10th year anniversary of continuous human occupation in space. In July 2011, the NASA selected the Center for the Advancement of the Science in Space to manage the ISS National Lab. In September 2013, the first ISS National Lab research site was launched. So, afterwards in the research, they created protein crystals. They were grown in the space. This also helped in developing many new drugs. After this, more flights were undertaken. Now, let us see the design and parts of the ISS. Now, let us see some basics. Every part of the ISS is called as a module. Nodes are a type of a module. They connect some parts of a station to each other. There are also solar array panels. They help to convert solar energy into energy. Sorry, the solar array panels help to convert the solar energy into electricity to run ISS. There are also robo arms. The robo arms are attached outside the ISS. They help astronauts to build and repair the space station, besides carry out experiments. Docking ports are like doors that allow the visiting spacecraft to connect to the space station. For example, let us take this. Here is the docking port, and here is a spacecraft which is coming to dock on the ISS. The spacecraft would join with this docking port, and the astronauts would go into the ISS. Now let us see the structure of ISS. ISS comprises 16 pressurized modules. 6 of them belong to Russia, 8 of them belong to US, 1 belongs to Europe, and 2 belongs to Japanese. ISS also includes habitation modules, structural trusses, photovoltaic solar arrays, thermal reactors, docking ports, experiment base, and robotic arms. The ISS power system is designed by the Japanese Aerospace. It is also the world's biggest DC power system in space. At least one Soyuz spacecraft is always docked as a lifeboat and is replaced every 6 months. Now let us see the configuration of ISS. As you can see here, there are many parts of ISS. Most of them belong to US and some belong to Russia. As you can see here, these are the photovoltaic arrays. This is called as a Soyuz here. There are 2 Soyuz. This is the pressurized adapter. This is also a habitation module. The astronauts will live in the habitation module. This is the node 2. Now let us see the coordinate system of ISS. Actually, in the given image, you can see clearly the right side of the ISS is called as the starboard. The left side of the ISS is called as port. The highest point of the ISS is called the overhead, and the smallest or the lowest point of the ISS is called as the deck. The port refers to the left side of the ISS. The starboard refers to the right side of ISS. The overhead, which is also known as zenith, refers to the highest point of ISS. The deck, which is also called as nadir, is the lowest point of ISS. Now let us see the integrated truss assembly. The truss assemblies provide attachment points for the solar arrays, thermal controlled reactors, and external payloads. The integrated truss structure is made up of 11 segments plus a separate component called the Z1. As you can see in the given image, you can see this SO. It is the middle part. It is the middle part of the truss. And in the left side of it, you can see that P1, P3, P4, P5, P6. They show us that they are in the port side of the ISS. All the S1, S3, S4, S5, and S6 shows us that they belong in the starboard side of the ISS. Now let us see the solar array panel. The ISS electrical system uses solar cells to directly convert sunlight into electricity. This process is called as photovoltaics. The solar panels are two-sided. They allow arrays to collect sunlight from a wide variety of angles. As the station orbits the planet every 90 minutes. Even in space, the heat is an issue for solar panels. So the ISS system uses a series of baffles called as radiators. These radiators run along the base of the arrays and dissipate the heat away from the station. For example, let us take the heat from the sun is coming like this. Here are the solar panels and here is the radiators. These radiators would dissipate the heat away from the solar panels. Now let us see the racks of ISS. Actually, each array is mounted on an accordion folded racking system. This is also referred to blankets. There is one fascinating aspect. The fascinating aspect of the ISS rack design is that the way it compensates for the drag. For example, let us take this. So here there is the planet and here the ISS is revolving around it and here the sunlight is coming. When the ISS is in the sun is in the portion where the sunlight is fallen. So there the solar panels should be like this. So when the ISS goes into the portion where there is no sunlight, the solar panels would turn into its glider mode. So the drag force would be very light. It would very affect the ISS. And note, the drag can make the ISS move out of its orbit. For that only, this solar panels turn into their night glider mode. Now let us see about the batteries in ISS. The heart of ISS electrical system is its bank of rechargeable nickel hydrogen batteries. These nickel hydrogen batteries have a lifespan of 6.5 years. Since 2017, these batteries are replaced by smaller but more efficient lithium-ion batteries. These lithium-ion batteries have a lifespan of 10 years. Now let us see the operation and now let us see how we manage and operate the ISS. So, as you can see in the given picture, there are many centers around. There are many centers around the world which manages and operates the ISS. For example, in North America, there are many, and they extend till South America. In Europe, there are many, and they extend till Asia. Like that, there are many centers. They help in maneuvering the ISS. They also make the ISS go into different orbits and many more. Now, let us see some success stories of ISS. Now, there is a huge spin-off from scientific experiments in ISS, like commercializing LEO. Like there are many people like Elon Musk who are traveling to space and come back to Earth. This is called as the commercializing LEO. Actually, this also supporting water purification efforts for worldwide, using a robotic arm for tumors, preventing bone loss through diet and exercise, developing improved vaccines, providing students opportunities to conduct their own science in space, monitoring the natural disasters from space. They also improving the indoor air quality. Now let us see the future of ISS. Now ISS is approved to operate until 2028. There is also a Chinese space station which is called as Tiangong, which is currently being built. India is planning to construct a low Earth orbit space station which is capable of housing a crew of 3 members for up to 20 days. This would be after Gaganyaan mission is success. The NASA announced plans in 2017 for the Lunar Orbital Platform Gateway. It is a manned station orbiting Earth's natural satellite or moon. Russia in March 21 announced that their plan is to build a lunar station, which is also known as the International Lunar Research Station, on the surface of the moon by 2031. Now, we also about ISS. Now, let us come to a conclusion. The ISS has been an epitome of the international cooperation of leading nations in space technology. They had put aside their ideological and political differences to bring about this successful endeavor. ISS is the springboard for future manned explorations to moon, Mars, and outer space. Humanity's quest to conquer space is well on course. Thank you. Now I have a small quiz on ISS.
Wait, Adhrit. So nice. You can
any questions
yes,
for you? You can ask.
If students, if you have any questions, you can raise your hands. And meanwhile, you can put your quiz link, Adhrit, so the students can start joining side by side.
Jagu will share it.
Okay.
Jagu, can you see this?
Yes. Yeah. Just click the link, no?
It is joinmyquiz.com. You need to click that. You need to type that link and then you need to enter this code.
No, you can just
545841.
Adhrit, can you come down below the number? Can you see one chain kind of icon?
Chain?
Yeah. Click on it. Click on it. Now paste it in the chat box. It got copied already.
Okay, Jagu, just a second. I'll come back. Just a second. I'll share it. Just a second, Jagu. Jagu, this is the code and the link is join my quiz.
No, now you can paste it directly, Adhrit.
Okay, Jagu.
Yeah. Just click on the chain and you can paste it. No. This you are pasting the admin link.
Sorry, Jagu, this is join my quiz. .co. Jagu, that's the link.
Okay. Nice. Okay.
And then you need to click that code which I gave to you. 545841.
Okay. So you they need link actually. So okay, wait. 548 545.
841.
Try this. I don't know. Because I will try to get the link as well. 545. What's the number?
841.
841. Let me try to grab the link for you. 54584. Okay, I think guys, you need to. Adhrit, you can only do the paste the link.
Jagu, I don't know how to paste that link.
Yeah. Just click on the chain icon. Yeah, click on it. Game link copied to the clipboard. Now paste it. Just click paste in the chat box. Got it. See, you're sending me directly. No issues. I'll go. Okay, we got the link. Ta-da! Student, you can join now. I'll post this in live as well. Okay. Did you mute yourself? No.
Jagu.
Okay, done. How many are joined?
Jagu, waiting for participants to join.
Okay. I think students you can join in. Next we have Avinash to present. Avinash, you want to go next or we ask Kashika? Yeah. Oh, you're muted. You can put it in chat box. Refresh it. I mean, Adhrith, refresh. I'll do next. Okay. So Avinash is going next.
Sir, many participants are
Okay. Start. You can start. I think it's almost. Yeah, it's 14. You can start. Okay. Adhrit, you can click the questions so that I can read the questions for the audience. Or you yourself can read out the questions. Just to get the answer.
How many missions were sent to assemble ISS in space?
More than 40, less than 12, less than 62. How many missions were sent to assemble ISS in space? So it's students and viewers, ISS is not a single piece. It's built piece by piece. It's like some 20, I think 1998 to, I think it's more than 23 years of hard work. The next question.
How many space agencies collaborated and built ISS?
Then how many space agencies? It's not only work of one agency like NASA. It's like collaboration of several countries actually. Russia, Japan, I think it's a lot of countries involved in this. Then third question.
Third question is, which one of the following is a success story of ISS?
Commercializing low Earth orbit, preventing osteoporosis through diet and exercise, improving indoor air quality, all the above. Okay, quite technical question only. ISS cleared to operate till 2028, 2031, 2073, 2040. I think if you listen to Adhrith's presentation, you might be able to answer. The ISS travels at the speed of 759 miles per hour, 15,500 miles per hour, 44,566 miles per hour. Nice. So this, if you are in younger society, you might be knowing this. We discussed this several times. Which of the following are some of the space agencies that helped build ISS? ESA, Roscosmos, CSA, ISRO. Nice. I think there you know the answer. I already said it as well. Okay. Answer question 7. ISS uses which of the following source for generating power to sustain itself? Lunar energy. Okay. Nuclear reactor. Okay. Wind energy. Very nice. Solar energy. The question itself has the answer, I guess, because it's so obvious. But it's a nice question. Actually. Well thought. How many space stations, to our knowledge, have so far been built in space? 3, 5, 2, 4. I know quite a lot. Okay. But the answer is in this number. Okay. Stree is leading the board. Let's see the next. Go up, go. Stree, Riansh. Okay, Riansh. I usually consider who have finished it first. I keep them as leader, like winners, because there are sometimes people get to join it again and again. That's fine. Rakama is jumping up now. Okay. Satyagi coming up. Okay, so it's from here, Sri and Riansh. Okay. And they are very close, only 10 points. I think how many finished, Adhrith? I think 22 done. You can end it. You can end it.
Okay, Jagu.
Yeah, yes. End it. Ta-da! Well done, Sri, Riyansh, Satyagi. Well done, well done. And Sri and Riyansh is almost they're like only 10-point difference, and they answered everything right. Well done, Riyansh and Sri. And well done, Adhrith. It's a very good presentation. Whoever wants to know more about ISS, they can actually go through your presentation. It had a lot of details. Well done. Thank you so much.
Jagu.
Students, I'm going to unmute all of you. Let's give one huge round of applause for Adhrith.
Thank you, Jagu, for giving this
Yes.
opportunity.
We can stop sharing so that we can see all their faces.
Okay, Jagu.
Okay, wait. Let me put all in a grid so that now, yeah. Thank you so much. And let's welcome.
A person named ERD 7B A60 has a doubt.
Okay. Yeah, you can ask your doubts, students.
What is the full form of ISS?
International Space Station.
Hey,
Okay, Anna.
Okay. Next doubt. Who has the doubt? Satyagi. Yeah? Satyagi, you can unmute yourself and ask the question.
No doubt, sir. Sorry, sir.
Okay. Nice. Well done, Adhrith. Okay, let's welcome our next future scientist. That's our AD. You must be wondering what is AD. He will reveal himself. Before that, let me introduce our AD. AD. So this AD is from this company called Solo Traveler. So all names looks anonymous to me. AD, Solo Traveler, and he is from SCA Chennai. Fine. And his presentation, he came up with his own equation, and he is going to show some proof of his equation. And I am actually wow. And he is in grade 9. So grade 9 comes up with his own equation. I will say Newton in the making, Einstein in the making, Ramanujan in the making. Anything. Let's see. Let's welcome Avinash. Avinash, wait. Oh, I need to unmute Avinash. Avinash? Yeah. Done.
Yeah, okay. So, hello everyone. This is Avinash here. Well, AD is my full name. That's my initials. AD is my full name, Avinash Dilip. Now, I'm going to present something in a minute. Just give me a second. I'll present it right now. Having some troubles presenting. Yep. Yeah, okay. Just a minute. Yeah, now can you see my screen?
Yes.
Great. Happy to hear that. So, welcome everybody. This is Avinash here. Today I'm gonna make.
I know E is equal to MC square. Any of you know what is E is equal to MS?
Yeah. So now I'm gonna prove my equation E equals MS. So now the content is researched and presented by myself, AD. Now, before going inside, let me give you a set of guidelines. All the guidelines for today is the same as the guidelines given last week. Interactions with me are allowed, but with others, no. I have a pen and a notebook with you today, as we'll be doing some math problems today as well. And yeah, if I'm not talking properly, I'm sorry. I've got braces in my mouth and yeah, it'll be a little tough for me to talk for now. So yeah, now let's go back in time to when last week Sunday at 8:45 p.m. I'd mentioned my equation E equals ms, and the explanation to that is given below as a little extract from the previous presentation. It shows the energy used when a body of mass m moves at a speed s. The equation can be used to find the energy used by a body. Well, this is partly right and wrong. This will show the energy used by a body, but won't show the exact one. This should give you a very vague and a very vague average. That kind of an answer. So I don't think that will be of any use. But don't worry. Now I'm going to take you back to Gopalpuram. Okay, that was on 30th August, if I'm correct. Yeah. On this day, I was thinking, how could we prove that equation physically and mathematically? That's when the idea popped up. Why not a new equation derived completely from the old equation E equals ms by t? So I got to work and I'm presenting you the newest equation E equals md by t squared. Well, what is that equation and how does it work? Now E equals md by t squared is an equation that's going to give an answer which is near the bullseye. By bullseye, I mean the exact answer. We'll give or take 1 or 2 calories, which is equivalent to 4.1 or 8.3 joules. This equation will find the energy used by an object in motion, like the previous equation. Okay, now I want you guys to raise your hand. Okay, now I'm going to ask you guys a question. Those who have understood, raise your hand.
Unless you want me to allow unmute option?
No, Jagu, please.
No? Okay.
Don't allow them to.
Okay, then fine. Just raise your hands or put it in chat box. I'll unmute or depends on.
Just raise your hand.
Yes.
I won't answer your doubts now.
Yeah, we have Prathunan Venkat raised his hand.
Prathunan Venkat. So it means you understand the equation, right?
Yeah, you can type. Shall I unmute him?
Yes, Jagu, you can.
Okay, Prathunan, you can unmute yourself.
So you understand the equation. Good. Okay. So Kashika, you also understand the equation, right?
Kashika can unmute.
Yes, I do.
Okay, Kashika, thanks for the confirmation. Now let me continue. For those people who didn't understand, don't worry, you're not alone. Even I didn't understand at first, even though it's my own. A dog named Dom, a Chihuahua, participates in the canine Olympics. I'm sure there will be one soon, or I guess there are some already. He runs 100 meters in 5 seconds with a constant speed. Find the energy used by Dom if he weighs 1 kilogram. I'm going to give you guys 1 minute time. Just calculate with the equation equals mv by t square. Those who understand, just write out and put your answers in the chat box. I'm going to switch off my video.
Okay.
I do feel quite uncomfortable right now.
Okay, let's check the chat box. I have one doubt. Okay, Satyaki has a doubt. Avinash, you can keep giving instructions if they want.
Yeah, sorry.
A dog named Dom, a Chinchuahua participant.
Chihuahua.
Chinchuahua. It's like Oumuamua. Visitor from outer space. Chinchuahua participates in the Canadian Olympics. He runs that 100 meter in 5 seconds with a constant speed. Find the energy used by Dom. If he weighs 1 kilogram, you should use AD's equation. E is equal to md by t square.
Okay. Hemashri has got
20 joules.
20 joules. Okay. Good job. You're correct. No.
Well done, Hemashri.
No. Sorry, you're not.
You are not? Okay.
She has actually not used it correctly. Hemashri, I want you to correct yourself. 1.33. No. Satyaki, you're also wrong. Just a minute. So, Hemashri, I want you to take T as T square, not as T. I understand your mistake. It should be T square, not T. So once you calculate that, tell me.
Okay.
192. Anish, Noda, your answer is definitely wrong. Okay, now leave it. Now I'm going to give you guys the answer. You guys will be shocked. See, by using the formula E equals, no Satyaki, you're still wrong. You're still wrong. That's still wrong, da. Sorry. Now by using my formula, we can obtain the answer. First, we substitute the values of m, d, and t square with the given values. Then, no, let's see. Vignesh and Irud, wrong, da, wrong. Then we'll get t is equal to 100 by 25. Why 25 when t is given as 5? Well, it's given as t squared and not t. And here E is given as joules, not calories. So it's not going to be 4 calories. So it's going to be 4 joules. Now, before we proceed, we have to check if there is any value that can be simplified. And if there is, it must be simplified. And there is one such value. 1 into 100 by 25 can be simplified as it will become 1 into 4 by 1 or 1 into 4. Then we'll get an answer of 4 joules. And that does not even amount to 1 calorie, just 4.184 joules. So now if I say what the amount of that is the energy burned in calories, you'll be shocked. It will be 0.9560229445550. That much calories. It's just a very little amount. Okay. E road 7B A Satyaki to me. I didn't understand the formula, Anna. Satyaki, do one thing. I'll explain the formula once again. Wait. So now, coming to physical proof. By that day, I'm gonna take you back to, if I'm correct, it is Thursday or Wednesday. No, it's Thursday. Me and my dad went out to play some badminton. And during the time, I asked my dad to measure the distance from one point to another. That distance was 14 meter actually. and I ran from one point, that is the, and by that point, Vignesh and Vidya are giving the answer after I reveal the answer. Noda. You're correct only, but you're giving the answer after I will show the answer. Okay. Now, by where was it? It's on the terrace of my apartment. So it's 14 meters from the that is the side facing another building to the door, which takes you inside the apartment. The distance between those 2 points is 14 meters or 47 feet. Not 47 actually, 46 feet. Oh, no problem. Now, when I use this equation, so I ran from one point to another in 4 seconds, and then later I checked my weight. It was exactly 47 kg. Actually, that's actually correct for me. That's good for me. That is a normal weight. Overweight, no weight. That's a normal weight for me. Well, when I used this equation, I found the energy to be 4 into 40 by 25. So 8 by 5. 4 into 8 by 5. So that will become 32 by 5. No, that will still be wrong. 32 by 5, you'll get around 8. No. You'll get around 6.4, da. So check your calculation again, da. You'll get around that much only. You'll get around that much, which is high. So I found that the energy used was 9.82 calories or 41.125 joules, which was a pretty reasonable amount of energy, and was just around 1 or 2 calories above the energy I had actually used, just 8 calories. And I was surprised to see that it was exactly what I thought it would be. A result where the average is not at all vague. Okay, now mathematical.
Yes.
Oh, sorry.
What is the question? Repeat, Avi.
Let's see. Okay. Just a minute, Vignesh. I'll repeat the question for you right after I finish this. So we can prove it from the old equation, E equals ms by t, like this. S here. Okay, just a minute. I'm gonna activate a laser pointer. S here stands for average speed, which is distance by time. Now substitute S, that is average speed, with distance by time, and then you'll get the equation E is equal to md by t by t. Now that t goes down and makes the equation E is equal to md by t squared. That's how you get the equation from the old equation. Now, questions. Unfortunately, I do not have a quiz today. Well, I was since there was a lot of this, since the response was poor last time, I decided not to go for a quiz. I'm giving you questions. Now, I want to make sure that everyone has a notebook by their side. Do you guys have a notebook with you? Switch on your videos. I want to see a notebook by your side.
I think most of them must be in front of the computer. You can open your notepad at least.
Okay. Just a minute. Let me open. Yeah. Okay. I only see Adhrit's face. What about the others? I want to make sure you guys, those who are in front of a notepad or a notebook, raise your hand.
We have a few hands. Let's see, Rian, Adhrith.
Continue. Okay, others, please. Your participation is what's going to define or is going to help me improve. If you guys are not going to participate, then you're not good. Then don't expect any improvement. Okay, so please participate. Tell me my faults. I'll do all my best to improve. Okay, Pratun and Venkat, okay. Vignesh and Niru, I'll tell you the question later. What is the equation again? Okay, Kashika, the equation is E equals md by t square. Yes.
Avinash, you can also put what is E, what is M, what is T.
Oh, you want that also?
Yes, yes.
Sorry, I forgot to write, but I'll tell you.
Because for the audience watching in YouTube,
Yeah.
for the audience here, we regularly interact. But for the audience watching in YouTube, for them it will be like little.
Yeah. So for those audience, I'm writing E equals energy used. So this is E. Okay. Now I'm going to remove this and then M.
Yes.
M is equal to mass of an object. Now, then let's go to D. D, I'm not going to write it down. It'll take a lot of time. I'm not a good writer. I can't write very well on a computer. I'm using a mouse. I'll show the questions now. Wait. I'll show the questions. T is equal to distance traveled. T is time taken. Now let's go to the questions. Now let's start. Imagine you're running a 100-meter race. You run the race in 20 seconds and by the end of the race, you burn 10 joules. Find your weight with the help of the equation. So guys, if you guys have a notebook, utilize the notebook. Don't waste pages. Okay, Vignesh, Noda. Your answer is still not correct. Guys, those of you who have got the answer, please raise your hand. Otherwise, lower your hand. I don't want to get confused. So, those of you who have got the answer to this question, may raise their hand. First question only.
Let's see. 5 joules, 2 kg. Riyansh, 40 kg. So they are putting the answers down.
Riyansh is getting 40 kg. Vignesh is getting 2 kg. Satyaki is getting 5 kg. Kashika is getting 40 kg. Okay. Yeah, so Riyansh and Kashika, you're right. The answer is 40 kg. Keerthana also, you're right. The answer is 40 kg. Now, I want one of you guys, any one of you, Riyansh, Keerthana or Kashika to come and explain how you got it. I just want to know. Or Adhrit also. Yeah, Riyansh, you can explain that, please. Next question I'll ask Kashika to do then.
Avinash, you want me to unmute Riyansh?
Yes, Riyansh. Hello?
Yes. Riyansh, you can.
Yeah. So Avi, should I annotate on the screen and show or how? How do I do it?
No, you just have to tell.
Yeah. So what do is we substitute the values of energy which we have. Like then the equation becomes 10 is equal to mass into distance, which is 100 meter upon time square, which is 20 into 20, 400. So then you can cut the two zeros and you are left by m upon 4 is equal to 10. And then you take 4 to the other side because multiplication 10 into 4 equals 40.
Good. Correct. Good job. Now, second question. Usain Bolt runs 400 meters in 10 seconds. If he weighs 90 kilograms, find the energy used by him. Actually, that is his weight. It's 94 kilograms, but just an weight. Okay, Kashika for the second question has given 360 joules. Riyansh has given 360 joules. Satyaki, which question, da?
Avinash, let me know if you want me to unmute anyone.
No, Jagan, not now.
Yeah.
I'll tell. Satyaki, which question?
Like,
First question. Satyaki, first question is given right here.
yeah, you can see in the screen.
Imagine that you are running 100-meter race. You run the race in 20 seconds, and by the end of the race, you burn 10 joules. Find your weight with the help of equation. Okay. Okay. Okay, Avinash. Okay. Yeah, so 360 joules is correct. It's the correct answer. Oh, you want me to explain it? Okay. Suppose you are running a race, a 100-meter race, and you finish it in 20 seconds. And then by the end of the race, you burn 10 joules. That is the amount of energy you burnt is 10 joules. Now you need to find the weight with the equation. So I think Riyansh explained the question. And Satyaki, yeah. So is it possible if you can contact me personally? I'll explain the question in detail then, because I don't want to waste any time right now. That's fine. Just send your number or mail ID personally to me. That'll be fine. Yeah. So yes. That's all, Satyaki. If you just, I thought Riyansh just explained it just now. Okay. Not just send your number or mail personally to the Zoom personally. I'll explain it. I'll call or send a mail and explain it. No, I don't want to waste a lot of time now. Okay. Yeah. So the answer is 360 joules. Correct. So now I'd like Kashika to come. Kashika to unmute and explain.
Okay. Ashika, you can unmute yourself.
Right. So the second question. So first, let's note down the equation. That is basically E. That is energy is equal to mass times distance by time squared. So we just have to put the values together. So Usain Bolt runs 400 meters. So 400 meter here is distance. So I'm putting 400 in place of D. And then it is given 10 seconds. But then according to the equation, we have to use 10 squared. So divided by 10 squared. So, because time is squared there. So it is given that 90 kg. Usain Bolt weighs 90 kg. And in place of mass, I'm going to put 90. So basically, the final form I get is that I will get 90 into 400 by 100. So we have 2 zeros in the 100 and 2 zeros in the 400 in the numerator and the denominator. We just cancel those 2 zeros. And then what we are left with is that 90 into 4, that is 4 into 9 is 36. And then we have 1 zero balance. So that is basically 360 joules.
Okay, Kashika, you're correct. You have explained it well. Good job. Now, for the third question, Avinash, weighing 47 kilograms, runs a distance of 500 meters in 40 seconds. Find the energy used by him. I'm not sure if that's even possible. 14.6875. Okay. What about the others?
Let's see who answers. We have 3 hands.
Ranadi, Freddy, and Tuni. 0.367185. To which question?
Oh, another question.
No, Randeep, it's wrong. It's wrong. Check your calculation again. Use the equation as I told. Use that, it will be easy. .6875 joules, third question. Okay. 11.325 joules. Okay. Yeah, so the answer is 14.6875 joules. Now, who got it correct? Kashika Riyansh has explained. Is it possible for Nivas, M. Nivas, to explain? If you want to explain, you can explain that. Not, I'll ask someone else. That's fine. I can go. Okay, Kashika, just a minute. Let M. Nivas. Okay, no response. I think, yeah, anyone here can go. Kashika or Young. Whoever wants to go can go. Can explain. Please.
Okay, so it's the same thing like the previous question. So you write the formula down. E, which is energy, is equal to D into M upon T square. So then you get D is the distance, which is 500 meter, into the mass, which is 47 kilograms, upon 40 square, which is the time square. What? So you get 47 into 500 by 40 by 1600, 1600, and then if you solve it or use the calculator to any stuff like that, you get the answer as 14.6875.
Good. Good. Yeah. So it's correct. The answer is correct. The explanation is correct.
We
So,
have Kashika, Nivas, Riyan, Sugadut, right?
so most of you have done. So I'm happy with. So
Well
I'm
done.
happy that some of you have interacted with me. It means a lot. So
This is how Avinash AD, this is how we prepare for IIT JE and all. Yeah. So you take a equation, find a real time real time thing, and apply the equation. So that's how it works. Well done, well done.
Thank you.
So
And this who logged in as Q teenager.
cute teenager.
Yeah, whoever logged in through that account, yeah, your answers are correct. Good job. Yeah. Now let me leave. My teeth paining a lot. All these braces. So yeah. Thank you everyone. Thank you for
Well done.
the wonderful
Let's.
interaction.
I think all of you can unmute now and give one huge round of applause for Avinash.
Awesome.
Jagu, I have a question.
Okay, good that I didn't hear.
Yes?
Jagu, I have a question.
You have a question? Yes.
Yeah, please.
Yes. Anna, where do we use this equation? Only for calculating problems or
You
any
can-
other uses, applications of this?
Okay. So applications is you can use it for calculation of movement of objects. That is, you can find how much energy an object loses by during its motion. Using this equation, you can calculate that. It does not have to be a human. It does not have to be a human necessarily. It can be anything. But regarding something else, you have to think, like planes, you've got fuel and all these, so you have to think regarding that. But if you take a normal object, okay, just a minute, let me switch on my video. Yeah, now can you see me?
Yeah.
Okay, now if you take a normal object like my phone here, okay, just a minute, let me switch off my background, that will be much visible. Okay, so now if I take a normal object like my phone and then push it across, and then just push it across, I can calculate how much energy it loses. By just pushing across, how much energy it will lose by moving. So I can calculate that. It can be used for calculations in energy consumption. That is the usage of energy by an object that's in motion. It does not have to be a human. It can be any object except for anything that runs on fuel. That is, it moves while running, moves with the help of fuel, like a plane or a car. I'm not sure about the car, but plane, I think it is quite tough to calculate. I have to check again, and then I'll get back to you regarding planes thingy next week. Not next week, of course not next week, but anytime soon. I'll get back to you regarding that. Yeah, so that's all I've got to say. And I'm done. So
Nice. Well done, Avinash. I think hope if you have any more doubts, you can put it in chat box all the time because we are here.
no, you don't have to put it in chat box, please. I'm leaving
Or
right
you
now.
can
As I
message him, mail him directly. He will.
yeah, I'm gonna send you guys my. I'm gonna give my mail ID right now. You guys can mail me, And if you want to contact me, you can ask Jagu for my contact number.
Yes,
I
yes.
will give it to you. So here's my mail ID. You can contact me whenever you want. You can expect a reply between 2 o'clock and 6 o'clock, or 2 and 9 o'clock. Sorry, 2 and 9 o'clock. Between these two times, you will get a reply. That's all I've got to say. You can
Okay.
message me whenever you can send any mail. You can send a mail to me whenever you want, but expect a reply only between 2 and 9. That is on weekdays. On weekends, you can expect a reply between morning 7 o'clock to night 9 o'clock.
Okay. Well done, Avinash. Okay, let's. That's well done, Avinash. Now we have our next presenter, who is going to present it for the first time, and she's one of the selected students from Isha Vidya school, and like, so out of the entire Isha Vidya school group, we got 70 number of students to join in our programs. So out of which we have one of the brilliant students is
Sir,
there.
your voice was
Okay.
breaking.
So now she is studying grade 9, Isha Vidya Matriculation School, and she's going to present on the topic about the planet Jupiter and 4 moons. Let's welcome Keerthana. Yes, Keerthana, the stage is all yours. You can unmute yourself.
Yeah, Jagu, Namaskaram, Jagu. Is my screen is
Yes, yes,
viewable?
yes. You don't mute yourself. So Keerthana, you need to unmute yourself. If your network is not good,
Yeah, Jagu.
you can switch off your video till you
Namaskaram.
you can switch off your video till the presentation is finished. After that, we can have interaction.
Yeah, Jagu.
Yes.
Yeah, Namaskaram, everyone. My name is J.R. Keerthana from grade 9. Today I am going to present a presentation on Jupiter and the 4 moons. Let's see. On the planet Jupiter, and the moons are Io, Europa, Ganymede, and Callisto. First of all, let us see about planet Jupiter. We all know that the Jupiter is the fifth planet from the Sun and in the solar system. And the Jupiter is the biggest moon in the biggest planet in the solar system. And first of all, let's say about its color. Jupiter is a gas planet with an outer atmosphere that is mostly hydrogen and helium with small amount of water droplets, ice crystals, ammonia crystals, and other elements. Clouds of these elements create shades of white, orange, brown, and red. You can see in this picture they are the colors. If anyone knows how many moons does Jupiter has, they can answer. If anyone knows how many moons does Jupiter has, can answer.
Yeah, students, you can answer in chat box. I think most of you know. Okay.
No one?
Rian's answer. It's 79,
No.
82, 62.
Let me check. Yes, Rian's answer is correct.
Yes, Rian's answer is correct. 60.
And is anyone know that who named the planet Jupiter?
Who named the planet Jupiter? Answers welcome in the chat box.
No one knows. Okay, let's see about that next. Yeah, your answer is correct. And Jupiter has 79 moons. So let me tell about that. Yeah, 79. Jupiter has 53 named moons and another 26 are waiting for their official names. Now the scientists are thinking that Jupiter has 79 moons, and in that moons there are 4 biggest moons. Now we are going to see about that only. And what keeps the Jupiter moons in orbit? With a total of 79 known moons, including 4 large moons known as the Galilean satellites. Jupiter almost qualifies as a solar system unto itself. Its size plays a role in the number of moons orbiting Jupiter because there is a long area of gravitational stability around it. Too many supporting many moons. So no one knows the answer.
God, Roman, Greek god. I can see few answers now in the chat box.
Okay, let me tell about that. Who named Jupiter? Jupiter is the largest planet in the solar system. Fittingly, it was named after the king of the gods in Roman mythology. In a similar manner, the ancient Greeks named the planet after Zeus, the king of the Greek pantheon. So, the Roman mythology were named this Jupiter. And then let us see about is there oxygen on Jupiter? What are some of the gases on Jupiter? Let us see about them. There are some of the gases like nitrogen, helium, and ammonia. There is no oxygen on Jupiter like there is on Earth because of the plants are in the Earth dioxide. Now let's see about you can see in the Jupiter's picture like there is a red hole that is called as the Great Red Spot. Is a storm in Jupiter's southern hemisphere with crimson colored clouds that spin counterclockwise and wind speeds that exceed those in any storm on the Earth. The Great Red Spot has slowly changed over the years and is currently about 1.3 times as wide as our planet.
Keerthana, are you there?
Yeah, Jagu.
Okay.
Yeah.
Yeah, suddenly silent actually.
No, it was taking to me so only.
Okay.
So some of them notice that what is the red hole on the planet Jupiter. Let us see about them. That red hole was named as Great Red Spot. It's a storm in Jupiter's southern hemisphere with crimson colored clouds with spin counterclockwise at wind speeds that exceed those in any storm on Earth. The Great Red Spot has slowly changed changed over the years, and it's currently about 1.3 times as wide as our planet. So everyone can understand this, I think so. This is known as the Great Red Spot. This is the storm of the hemisphere. So let us see next. Now we are going to see about the first moon, that is Io moon. Generally, these 4 moons are called Galilean moons or Galileo moons. How old moon O? About 0.5 billion years ago, this Io moon were named, and age Io addresses the age of Jupiter, which moon also has. Io is the 5th moon from.
Keerthana, your voice is breaking. Hello? Okay, she got disconnected. Let's wait for 2-3 minutes. And meanwhile, if it takes a little more time, we can ask our next presenter, that's Kashikaa. Yeah, she must be having some internet issues. Yeah, she's back.
Yeah, Jagu.
Yes.
I came back.
You can share your screen. You can keep your video off so that you can. Did you mute yourself?
Now, Jagu, can you see my
Yeah,
screen?
I can see your screen.
Let me tell about how old is Jupiter moon Io again.
Yeah, please.
Yeah. Now let's see about how old is Jupiter's moon Io. About 4, and its ages, Io is about 4.5 billion years ago old, about the same age as Jupiter. That means what age that Jupiter has, that age only this Io moon also has, and its average orbital distance is about 2,62,000 miles, and Io takes 1.77 days to orbit Jupiter. So this Io moon is taking 1.77 Earth days to orbit that Jupiter planet. So let us see next. Yeah. NASA Galileo space aircraft got Jupiter's moon Io, the planet's 3rd largest moon, undergoing a volcanic eruption. Most of Io's surface has pastel colors punctuated by black, brown, green, orange, and red units near the active volcanic centers. Io is the most active volcanic world in the solar system. So this Io moon has a volcanic eruption undergoing that was punctuated by the black, brown, green, orange, and red units of these colors. And this is the most volcanic world in the solar system. And the next question is the moon Io volcanic? Jupiter's rocky moon Io. This moon is the Jupiter's rocky moon and is the most volcanically world in solar system, which of nose. Some erupting lava fountains dozens of miles or meters high. Some of the lava are erupting like the fountains dozens of miles. How often do volcanoes erupt on Io? About once every million years. Io's volcanism so extensive that it gets completely resurfaced about once every million years or so. Actually, quite fast compared to the 4.5 billion years ago. Is there still lava on the moon? The moon has been volcanically active throughout much of its history, with the first volcanic eruptions having occurred about 4.2 billion years ago. Today, the moon has no active volcanoes, even though a significant amount of magma may persist under the lunar surface. In these points, if anyone has a doubt, can ask now, or otherwise, let's go to the next slide.
Students, you can put your doubts in the chat box. You can continue, Keerthana. I'll update you.
Yeah, Jagu. Now let's say about the moon Europa. Distance from Jupiter. Europa is the sixth moon of the Jupiter. Europa is tidally locked. So the same side faces Jupiter at all times. Size Europa is 1900 miles, 3100 kilometer in diameter, making it smaller than its moon but larger than Pluto. This Europa moon is smaller than the Earth's moon and they larger than the planet Pluto. Europa or Jupiter 2 is the smallest of the 4 Galilean moons orbiting Jupiter and the sixth closest to the planet of all the 79 known moons of Jupiter. It is also the sixth largest moon in the solar system. And then Europa is a frozen, icy world and is a unique object in the solar system. Scientists believe that beneath the frozen layers of ice on the Europa's surface, there is a salt water ocean in contact with a rocky sea floor. If this proven is for life to exist beyond Earth. Next, Europa is named after a Phoenician noblewoman. Europa's surface is younger than the moon itself. Unprotected humans on Europa would die within a day. Europa has a liquid ocean under its crust. Europa may have twice as much water as its ocean. Rexy is raising hand. I think so. He has a doubt.
I think by the end of the thing we can ask.
Yeah, Jagu. And then let's say about the moon Ganymede. Ganymede is the largest moon in the solar system and is larger than the planet Mercury. Ganymede is the only moon in the solar system known to have a substantial magnetosphere. Like Europa, Ganymede is thought to have a subsurface ocean overlaying a liquid iron and nickel core. And Ganymede and Callisto are planet-sized moon of Jupiter with surfaces composed of a mixture of dark dust and bright ice similarly in size. They both have interiors of ice and half rock metal. But Ganymede's interior appears to be segregated by intensity while Callisto's interior is mostly mixed. Ganymede as satellite. Ganymede, a satellite of Jupiter, is the largest and most massive of the solar system's moon. The ninth largest object of the solar system, it is the largest without a substantial atmosphere. It has a diameter of 5268 km, making it 26% larger than the planet Mercury by volume. Although it is only 45% as massive. And let's see about the age of Ganymede. It's also same age that as Io on the planet Jupiter. Ganymede is about 4.5 billion years ago, about the same age as Jupiter. Distance from Jupiter is this moon has 7th place and third Galilean satellite outward from the Jupiter. It's orbiting at about 6,65,000 miles, 1.070 million kilometers. It takes Ganymede about 7 Earth days to orbit Jupiter. And let us see next.
Keerthana? Yeah. Hello.
Yeah,
Okay.
it's hearing.
Yeah, I can hear you.
It's hearing, Jagu.
Yeah, I can. It's audible.
Yeah. About the moon Callisto. Yeah. The calendar named Jupiter is the second largest moon of the Jupiter after Ganymede. It is the third largest moon in the solar system after Ganymede and Saturn's large and the largest.
Okay, I think hearing got disconnected. Let's wait for a few minutes. And the students, you can share your thoughts about Jupiter, because we discussed a lot about Jupiter. she's back, and even one of our presenters used to tell Jupiter is a failed sun, like that.
Yeah, Jagu.
Continue.
Sorry, Jagu.
No issues.
And it is the third largest moon in the solar system after Ganymede and Saturn's largest moon Titan, and the largest object in the solar system that may not be properly differentiated. Callisto was discovered in 1610 by Galileo Galilei. Brownish Callisto is relatively brownish in color, possibly due to the contamination of the icy surface by meteoritic material. He wrote several books and proposed a theory he called the Callisto effect, which stated that evolved a creature so powerful and well adapted, a monster species, that is, triggers a mass extinction event. Yeah, and then Callisto was discovered Jan 7, 1610 by Italian scientist Galileo Galilei, along with Jupiter's three other largest moons, Callisto's statistics, and this rotational periods in days is 16.68902, and its orbital period days 16.68902. Mean orbital velocity km per second 8.21. Orbital eccentricity 0.007. Callisto is 628, 300, 000 km from Earth. Through a telescope, it is brighter in our sky than our own moon. Callisto is brighter because its surface is made of thick layer of ice which reflects sunlight more than our moon. Callisto is bigger than the planet Pluto but only has one-third its mass. Thank you everyone. I had completed my presentation. This is a quiz time. I will be sending the link in chat box.
Nice. Quiz time. Okay. Before that, if you have any doubts about on the topic or anything related to Jupiter, you can ask Keerthana. You can put it in or raise your hand. I'll unmute you. You can ask your questions or interact with.
Rexy is raising hand.
Yes, sir, Raksi.
Yeah, Keerthana, I not have doubt. I need to just tell a point which you have missed. Jupiter can be colonized or not being colonized.
Yeah.
I know the answer, but I will not tell.
Okay. That's the CEO of Target Space. Keerthana.
Yeah, Jagu.
So,
Can we colonize Jupiter or no? ஜூபிட்டர்ல போய் மனுஷங்க உயிர் வாழ முடியுமா முடியாதா இந்த ஃபியூச்சர்ல பண்ணுவாங்களா?
I think she does not know, but I know the answer. Just I kept an instruction. The answer is cannot be colonized because the Jupiter planet is full of gas. If a person goes into the planet, he cannot come out.
Okay.
So it cannot be colonized because of the highly gases.
Okay.
That's the main reason.
Oh, Keerthana, oh, sorry, she got muted. Okay, wait. I think she will answer. Yeah, unmute Keerthana.
No, we can't able to live on the planet Jupiter.
Yeah, I told it before itself.
She got muted.
I got muted, so only I was answered in chat box.
Yeah, so Keerthana, you can share the quiz link in the chat box.
Yeah. Jagu,
Yeah, Jagu.
But this thing I only learned that 2 years ago. I got the info. Like the Jupiter, I just see general info about Jupiter. As you know, I did a presentation about Neptune, Venus. 1 year, last month, 3 months ago, I did about Neptune, Venus, and Jupiter. No, on that I told it impossible.
Okay.
Because it's especially these are theories of mine. I have done 4 theories, out of which this is one. It cannot be colonized due to its heavy gases. Okay, when a person goes out, he cannot come. But a person goes out, he cannot come out. But some people are telling if we put an Iron Man suit and go into that, you can little bit come out of that planet. But usually it's impossible.
But the Iron Man is not real, it's just cartoon.
Okay.
Yeah, like that they are telling to make a suit and go. It's a cartoon, but it's you need to make a supersonic suit. Like the suit, how it should be is it should be like an Iron Man. Just for an example, I'm telling.
You can share your screen so that you can see the number of participants. Don't mute yourself.
Yeah, Jagu.
After this, we have Kashikaa to present.
Yeah, can you see?
Yes. How many parts you can refresh? I think if you refresh, you can see the parts.
Yeah, Jogo, sometimes for me also this will happen.
Let me start, Jagu.
Yes, yes. We have 13 participants. Yes. Start. We can mute the music. Okay. Start Aidija. Keerthana, you can read out the questions. Yeah. Who named the planet Jupiter? I'll read out the question. A leaderboard Kadesya Papa. Who named the planet Jupiter? King of the gods and Roman gods. Galileo Galilei, Greek gods. Okay. Jupiter is made up of helium, ice crystals, mostly helium and hydrogen, oxygen. How many moons does Jupiter have? 179, 780. Yeah, this was one. This was the answer. The answer is here. How old the moon Io? 2 billion, 4.5 billion, 100 years, 6 billion. This Io is a volcanic moon. Okay. Fill in the blanks. Okay. From the planet Jupiter, Europa is in which place? 6350. Which moon is larger than planet Mercury? Ganymede, Io, Titan, Europa. Another name of Callisto. Jupiter 4, Jupiter 1, Jupiter 5, Jupiter 3. So Jupiter has some kutti Jupiter. Okay, fine. Go next. 8 questions only. Yeah, check. Now let's see the leaderboard.
Now, can you see the leaderboard?
Not yet. I think Lord out. Yeah, I can see now. I can see now. Anish Noel is leading it.
Jagu, I think her network is a little low
No.
because I have finished the entire thing and I can see the
Oh,
leaderboard.
okay.
That's
Then you
why.
refresh. Yeah, just Keerthana, refresh it.
Refresh.
So yeah, actually I
There are many people who have finished the entire thing. That's why.
yeah,
You need to
it is
refresh a bit.
actually I finished it and I have in 8th place.
Okay.
So first thing I was
So Riyansh is leading 5330. I think you can finish after, I think timer vechikkanum before the student joins the second or third time. Satyaki is jumping up. எல்லா ஆன்சரும் கரெக்டா வந்துட்டு இருக்கு. I think after Satyaki you can end the quiz. Satyaki joined twice, then you can remove Satyaki. If he joined twice, you can remove Satyaki. So in that case, you can keep Riyansh.
You can end the quiz.
In that case, Riyansh is the winner. 17 players. I think you can end the quiz. End it. Let's see.
Yeah,
the
Jagu.
Jaggu, please. I'm finished. Just a
Okay, wait. So Adhrith is.
Sir, you can end it.
Yeah, you can end it. So Riyansh is actual leading the thing. Riyansh, Aishwarya, then we have Riya. Then followed by Riya, Darsh, Adhrith. Okay, this must be the, I think this is the leaderboard. Thank you, Keerthana. That's the first live presentation. Thank you so much. All of you unmute yourself and let's give one huge round of applause for Keerthana first presentation.
Amazing presentation, Akka.
Amazing, nice work,
Amazing.
nice work. And I'll add you in the young researchers too, Keerthana. You can do more such presentation in future. And let's welcome our next presenter. She is known for introducing unique ideas
So
in
next is
young
my chance,
researchers
right?
crew. That's our Kashikaa. And she is from grade 9 Kendriya Vidyalaya Ashok Nagar. And her topic is prevention of bird attack during aircraft takeoff and landing. So this much cookie bird, this much big airplane, this much cookie bird will attack aeroplane and it can cause serious damages. Who knows the answer? The momentum at which both hits is like they can cause some major crashes. Some already happened in history. And let's give Kashika is here to give more inputs on it. Let me unmute her first, then pin. Kashika, you can start. Hello.
Yes, sir.
Yes.
Hello, Jagu. So let me do a presentation. It's going to be really quick because I have another meeting. Yeah, I'm going to start presenting now.
Yeah.
We don't want to have any quiz today, but then we're just going to have a questionnaire today. So, right. So, so if you have any questions, you have to go to this link and then just put down your questions. I'll share this link with Jagu, and then could you just post it in the channel?
Yes.
I think I posted a bit earlier.
Nice layout. Bird attack on aeroplane and my solution for it.
I think it's like on top here. Yeah, I'm giving this link to Jagu. We'll put that in the chat box. So if you have any question in the middle of the presentation, I really encourage you to kind of ask the question then and there. So let's go ahead. So I'm going to make this as a two-part presentation. Where one of us will be speaking. So in the first part of the presentation, I'll be speaking about the bird attack, the influence of it, and then in the next part, I'll be speaking a bit about my solution here. And then in the later part of the presentation, I'll be definitely speaking about, more advanced skills because I have done the rough sketches until now, but then I want to make a blender sketches, and then I want to make a CAD file as well. So which I want to make it as a two-part presentation. So in the next future meet, you have to stay tuned to actually listen to that. So right. So I'm gonna start my presentation now. So first thing is the bird attack on airplane and my solution for it. So bird attacks are very, very, very common. It is right. So bird attacks really happen and they kill people a lot. So there has been a lot of support and it really does cost the airlines a lot of money because with how big we can use this money for some other good purpose, not just for humans or the airline company. It can also affect the birds as well, the bird itself. It has some surprising pictures in the presentation, which you can get your mind by thinking, right? So we all know that more than so there had been an incident that happened in 1988. There was a bird strike. Nearly 219 people were killed in that bird strike. So I think it was between 1990 and 2009, but this incident, the 219 people who were killed, happened in 1988. So between the period of 1990 and then 2009, there was a lot of bird strikes in the, in the U.S. civil aviation, and that cost them more than $650 million per year. And during those times, it was like a huge amount. So there were about like 5,000 bird strikes that were actually reported to the U.S. Air Force in 2010. So this is a pretty serious stuff. And then go to the next slide now. Next slide. Okay, why is this very important? As I said, more than 290 people were killed. So if we come up with a solution for this, we can save all those lives. We can save all the money that's being invested into repairing stuff, repairing all these damages that has been done. They have caused number of accidents with human causalities, but then they were over 13,000 bird strikes annually in the US state alone, in the USA alone, right? So, but the number of accidents that do happen, does not involve civil aircraft a lot, but then it's very quite low. It has been estimated that there is about only one accident resulting in human death in 1 billion. But then think about the cost. The flight, the aviation industry, they have to put a lot of cost towards this. We just have to come up with a simple, elegant solution that will keep the birds away, but not kill them, right? That's what it is. So let's go to this. So why do they attack the plane? So as I said, it's quite low, but birds do come up in the path, right? They do come up in the path of an aircraft, and then they do come up in being. So I have a picture in the presentation, right? I'm going to show you that picture. Look at this picture. This is an aircraft, and this is like the entire birds. Those are birds, they're complete birds. They're traveling around and around. And they're gonna hit the aircraft and people are gonna die, and then the pilot is sitting near the cockpit. But then people are taking countermeasures for it. But then there's like vehicle design, wildlife management, non-lethal. So vehicle design is basically we can modify the design of the aircraft itself, and then we can continue with the wildlife management, so if you have a doubt or question, you can just go to this link that was posted in the chat, and then you can just ask a question, and then we'll do a questionnaire session at the end of the presentation instead of a quiz. So so you have wildlife management, which control the birds, but I don't think that's very ethical, because we cannot control nature, right? Birds have their own mind, nature has its own mind, and I think that we should come up with a pretty solution that will keep the birds away. And then look at the spokes of birds that flying around this Airbus 360, this aircraft. That's really intense, because imagine if one of them gets in between the wing and cracks the windshield. Cracking the windshield is pretty uncommon, but then a bunch of birds does it. That's quite fun. So that's good. When it comes to non-lethal, there's so many things. There's so many things that comes under non-lethal. Like it can be broken into habitat. That is like the design, the inside of the aircraft, and then we can see how we can change the trajectory, or how we can use chemical repellents in the air. That's kind of I don't think that's very ethical to do, right? Because we cannot use chemical repellents like when you're on air. Okay. So let me go to the next. This is very short. So let's go jump into a little history, and then we'll go to the solution. So what happened is that, if you could see, there's an actual picture taken because it's a very old time, right? And then 1911, he was attacked by an eagle. That's intense, right? In the old time. But then now we have a pilot, little Theo Nobel, I think Nobel. He flew into a bird has flew into the nose radiator. So if you get this one, you see this image, how intense this accident is. And then the same thing happened with a Black Hawk after collision with a common plane. The Black Hawk is the name of the flight, and then the bird is right there. Look at the cockpit. Look at it. The bird is actually crashing into the flight, and then I think it's going to drive the plane. I think it has a wish to drive the airplane or something. But it has cracked the windshield, and then it's sitting in the pilot seat. That's kind of not good, right? So now let's go to the solution. What are we going to do regarding this? So here's my little solution. So we have to use something called the frequency sound generator. Frequency sound, it is kind of invented, but then we have to modify. Here's a rough diagram that I did, but then I want to do a little more advanced. So this is like part 1 of my idea, and then part 2 will be entirely dedicated to the solution itself. Because I want to design a program that can actually, can detect the shock waves, the bird's mass, and all those things that I have this in mind, but I want to put this into action. So I created this entire presentation within an hour, so I didn't get much of time to actually work a lot in this. But then I have started the vague idea for this, my solution part, and then I'm in the next part too. I'm going to discuss a lot about the solution. So a frequency sound generator. So that is my attack on the issue. So this will be fixed on the front, back, side, and side plane of the side part of the aircraft. So the frequency will obviously differ from plants to plants or birds to birds. And that's why we have something in mind that is it's going to detect the shock waves, and then it's going to detect the mass, the disturbance in the air. So that's basically how it's going to generate the amount of frequency that it's going to get. So if there's a big bird like an eagle, and then the frequency will obviously differ. We can probably give 6 hertz, and then if it's a small bird, we can give 4 hertz, right? So just to keep the bird away, not to kill the bird that's against nature. If you could see this little rough diagram, this is, don't think it is ice, but it's just a pilot. And then if you could see the X mark here, is frequency surgery will be placed here. You might ask if it's like open, how will we have the casing, the outer casing, how the frequency generator will be protected. We can have it, so in the front plane, we can have it inside, fixed it inside, but then a nose like cone-like structure will come out that is going to produce sound. And then we could do the same for all these 4 sides, but then at the end, we will not be able to do that. So that's where we'll be needing something called the outer case. But I want to work towards some biomaterial. So I have biodegradable plastic that is really strong, that is extremely strong. So that's where I'm leaning towards. So that is the end of the presentation. I know this presentation was really smart, but the next week in the future scientist meeting, we'll have a complete presentation dedicated to the solution. And maybe in the future, I can do one prototype, a small prototype of this idea that I was talking about.
Nice.
Any questions regarding this
I
idea?
think Darsh already has a question. Yes, Darsh, you can unmute yourself and ask your question.
My doubt is like, actually, the birds, how will they get to know that? Like some glasses are like so transparent, it will be like it's open. They won't get to know it is like inside that there's a cockpit. They'll just think it is nothing. So then, how is it a bird attack?
It is a bird attack. So if you could wait, let me go back.
No, I'm just saying like, and many times, and sometimes it will try to defend its shelter.
Or you're saying like it can think like the aircraft itself is an object to it?
Yeah.
Yeah, actually that's true. But then that's the issue. It doesn't know what it is, and that's why it attacks the aircraft. And
yeah, so why didn't we just do something?
This bird doesn't know that it is an aircraft. It just jumped right into it. So to avoid all these consequences, to actually protect the bird and to protect the humans inside the aircraft, we need to come up with the system, right?
I'm just asking, why don't we just use something which is less transparent?
Less transparent? You mean like the entire aircraft itself?
No, the
can
monitor we can just use, we can just use cameras instead of a window.
So what if we can use cameras, but what do you think, like in a very high foggy place? The pilot won't be able to see the sky itself where he's going.
Yeah, that's true. But with the windows, we can't see that anyways.
Yeah, but then the bird can detect the shock waves from the aircraft. So even though we make it, invisible, transparent, it can still detect the disturbance in the air.
Okay then.
I also wanted to ask anyone if you're interested in this. Maybe we could work on this together. If you want, you can contact me on my email ID, which I'll put in chat, or my WhatsApp. I think Jakusha has my WhatsApp.
Yeah.
Thank
Hey,
you.
done. Kashika shared a mail and Yuga, what is this?
We don't have an exact request, but we have.
Kashika, you posted on link on typed on slides.app.go.
That's a
You
question.
can post that as a link because some of the students asking what is this, how to use
Let
that
me
link.
go to that.
Okay.
I'm
Awesome
gonna share it.
presentation, Kashika. Yes, that's from Vidya. You have any doubts on bird hit or related to bird attacks? You can always mail her, message her. She has given her ID as well. So I'm posted that link in the YouTube live also. Okay, done. So I think Kashi, is there a quiz game?
No, exactly. We don't have a quiz, but I just thought like there will be a lot of questions in this
Yeah,
side because it's like an own solution and idea. I
got it,
didn't
got
have
it, got it,
much
got it.
questions.
That's welcome. Yeah. So these kind of ideas are welcome because you need to come up with your own ideas, theories. Yeah, that's how the science or the humanity will grow to next level. Find a problem statement, find solution for it. That can be a very simple as drinking water. So ಅದಕ್ಕೆ ಕೂಡ solution ಕೊಡುತ್ತೆ. So that can be any problem. The take from high level problem statement like traveling to Mars, Titan, or a very simple problem statement like walking on the street. So you can bring in solutions for anything. So that gonna contribute to humanity. Let's give one huge round of applause for Kashika for a brilliant presentation. All of you unmute. Yeah, you can unmute yourself and talk.
Amazing presentation, Akka.
And thank you, Kashika. Now we came to last presentation of the day. That's from our Chief Innovation Officer, CTO of Target Space, Darsh Rai. And he is from HRNPS Bangalore, grade 5. He's going to present on
Viralika
the
asked a
topic.
doubt.
He's going to present on the topic supersonic airplanes. Supersonic. This word always like it's a catchy thing whenever I hear supersonic, sonic, all these things. Let's hear more from Dash. Over to you, Dash.
Yeah. So hey guys, I'm going to talk about supersonic airplanes as Jagu sir said. So what is it? A supersonic aircraft. A supersonic aircraft is an aircraft able to go faster than the speed of sound. There were supersonic flights with Concorde. Its nose is bent so that the friction reduces. Elegant and fast, known for its sleek design, delta wings reduce friction further. They also fly at 60,000 height, two times as much as regular planes since the air is less dense, which means less friction. But why don't we use it? Two major concerns with supersonic passenger travel: noise and pollution. Traveling faster than the speed of sound causes sonic boom, which can be heard on the ground as loud explosions. So it is allowed to fly at supersonic speed only over the oceans. The next big issue was fuel consumption. It consumed fuel of 25,600 liters per hour while carrying 100 passengers only. Economically, it didn't make sense. European Concorde flown until 2003, the Soviet Tu-144 flown until 1999 were major milestones in the history of aircraft. What we need to figure out is how to do Concorde, but we need to do it safer, more efficiently, and more sustainably. NASA engineers have carefully shaped the profile of sound waves it creates as it bursts the air. Sound no more than the speed of a door slamming. The great aviation transformation begins with QUESST, quiet supersonic technology. Sonic boom happens when the air pressure reaches its peak and once returned to normal. This is known as an N wave. For the way the pressure signature data looks when plotted. Propellers shaping the aircraft with characteristic like a very long front nose and reduced noise. They are designated to prevent shocks from joining before they impact the observer on the ground. The result is S-shaped in signature. Prominent supersonic design fast forward to today. Fuselage designed for speed, reducing drag, supersonic performance. Shaped into a long, slender tube, the fuselage feature aims a high fineness ratio, the ratio between the aircraft's length and width, maximize the performance. Airframe, the supersonic speed and aircraft exterior can reach temperatures up to 260 degrees Fahrenheit. Airframe needs to be built to withstand the heat and keep its shape under the most extreme flight conditions. Delta using structure takeoff, balance low speed takeoff and landing with high speed efficiency. Propulsion engine needs to be propelled through breakthrough supersonic speeds. Extended nose to prevent shock waves that form from joining pressures with waves on other parts of aircraft. However, the extended nose won't have enough natural visibility to operate aircraft. To overcome this limitation, the pilots will see the ahead through a 4K computer monitor. Some cameras mounted above and below nose. This is called as external vision system XVS. NASA's X-59 QUESST could have the way for a new era of supersonic travel, could carry up to 120 passengers. Boom is an
Wow.
independently developing supersonic jet. XB-1, nicknamed Baby Boom, is a supersonic demonstrator. Overture is believed to be the fastest and most sustainable airlines for United Airlines. Virgin Galactic and Rolls-Royce 19-seat Exosonic, developing low boom supersonic jet possibility for serve future Air Force One. Elon unexpectedly shut down, citing large new capital requirement. Mach, unit of supersonic aircraft speed. Mach 1 means that the aircraft goes as fast as speed of sound. Supersonic is generally designated as the area between Mach 1 and Mach 5. Hermes, forget about supersonic. This hypersonic jet can fly up to can fly from New York to London in under an hour with a top speed of 5.5 Mach. Waterhouse can fly autonomously. Hermes is joining hands with NASA to build a commercial and defense application of future, leveraging technology from the day of Concorde rather than starting from scratch by turning sonic booms into sonic thumbs. Continues to have the way for a new age of mainstream supersonic travel built on speed, safety, sustainability. Building supersonic future. And happy Teachers Day for and thank you Jaggu and the team for teaching about aerospace and space and etc.
Thank you. Thank you so much, Darsh. I'm just amazed by the quality of images and layout you presented.
Thank
And
you,
it's
sir.
one of the advanced topics. Students, you can unmute yourself and ask your questions for that.
Yeah, sir, and I have a quiz also.
Quiz. Oh, okay, quiz time.
If anyone has any doubts,
How
Yeah.
many quiz?
what?
Yeah,
How
you can
many
put the
quiz?
link.
Okay,
Yeah,
but
you
does
can,
anyone has any doubt?
yeah. Yeah, you can put your like you can actually directly unmute and ask your doubts to
Yeah.
Dash.
The code is here.
Which website, Dash?
The quizzes.com.
Quizzes.com.
So now
Quiz.
We did not have a quiz.com. We put the link.
Quiz.com.
quizzes.com. Quizzes.com.
Yeah, I think you better you can share the link. Just share the screen. Let's see how to share the link.
Okay, sir, I'll share it. Share screen.
So they'll click and join. Share via. Below the number, can you see? Share via. Copy link. Copy link.
Okay, sir. I'll share it.
I need to put lot
one
of
second.
presentation as a separate videos because lot of quality content is just not getting time. Hopefully, I'll try to sit this week and put lot of videos in a separate.
Yes, sir, I sent it.
Yeah, I posted
Yeah.
it in YouTube live as well. Nice.
Yes.
Okay,
4 people have joined. Ready for others to join.
we'll at least get 10.
And this is a quite.
Anna, you share the screen.
Yeah, I'm sharing.
7, 8, 9, 10. Easily we get around 15. Is it a timed
Yes,
question?
sir, it's timed.
Okay, then wait for it. Wait for it because
Okay, sir.
we have almost 18 plus audience here.
Okay. Vignesh joined.
Students, you can join using link. Ria, I can put it in Isha group as well.
Darsh, can you? This is Meeda. Can you remove Vignesh and Adhrit because
Okay, done.
I just cut the tab, but it's not coming.
Okay,
Just
one
remove it.
second.
Click remove.
One
Click
second.
the before name. Just remove.
Yeah, that's put the info now.
They
Oh.
just remove that number. I'm only Red C.
That's not
Please
coming.
remove.
It's okay, leave it. Let it be.
Yeah, Jagu, but I mistakenly joined and I closed the tab, but my name is
Nothing will
still
happen.
there.
No, nothing.
Nothing will happen. Anyway, this is timer quiz, so nothing will happen.
I just joined in Red C only.
That's Vignesh is saying you can see that this thing now that press that one.
Okay, that one. Okay.
Yeah.
Now
I think you can start.
okay. Start.
Okay. You can read out the questions or I can read it out. Full questions for you. Well, QSST is acronym for Quest Supersonic Technology, Quiet Supersonic Technology, Quiet Small Sonic Technology.
Okay, now the time is up. So
nice.
So Vignesh is number first and Anish is
Nice.
so 2 people. So most of the people did a correct answer only.
Okay.
Next question.
Yeah.
Next.
Let's go. Oh yeah. Next. Next question.
Milestones in the history of aircraft. Concorde, Soviet Tu-144, X-59, Water Horse. Water Horse.
Yeah, time's up. Let's see who's.
This is like the jet. This is like supersonic speed.
So
nice.
yeah, most people did correct. Okay, now let's go to next question.
3, 2,
1, go.
Is the unit of speed
is the unit of aircraft speed.
Just fill in the blank.
Yeah, fill in the ones. How do you measure aircraft speed? It's a 4-letter thing.
Sir, please and give.
Okay. Because it's timed anyway. So,
Yeah, let us see the leaderboard.
oh,
So Vignesh is like number 1.
nice. Riya is jumping.
Now let's go to next question.
Two. Major concerns of supersonic aircraft in the past: noise pollution, sonic thumb nose.
So most people gave it correct.
Noise and pollution.
So
So
now
this,
let's.
so here's 2 answers for 2 questions. Nice.
Which supersonic dream?
Supersonic demonstrator is nicknamed after Baby Boom. X59A, X59, XB1, Area 1. Nice. Baby Boom.
So some 3 people are not answering only.
Because before they read, I think
So they,
Ishan. Hey, Ishan is here. Okay.
okay, so many.
XB1.
Okay, next question. Yes.
Yes.
Yeah.
Let's wait.
Let's see the leaderboard.
I think it will appear here.
So second. So
Ishan sudden, yeah, he came first. Then Keerthana. Yeah.
Here after lot of people.
Yes. Yes.
Yeah. So.
Well done. Well done. It's a nice presentation there. Neatly done.
Yeah, thank
Well
you, sir.
done, Darsh.
Thank you.
Well done.
Yeah. Oh,
Audience, you can post your comments.
Super presentation, Anna.
thank you.
You can post your comments in YouTube live as well, so that when we watch it again, that will be like a good memory to see it back. Because I don't think the Zoom comments are appearing in YouTube.
Yes, sir. I know that, sir. It's not appearing.
1 second, Zaka, I post in the live stream.
Yes. Yes.
Yeah.
Nice. So
Thank
thank
you.
you. So let's give a huge round of applause for Darsh. All of you can go unmute. And thank you so much for everyone who are watching us live. So we had 5 brilliant future scientists who had presentations. We had Darsh, Kashikaa, Keerthana, Avinash, and Adhrith. So all presented on different topics, and mostly they are from 6th to 9th grade students. These are the students who are going to change the future of space industry and take humanity to the next level. I strongly believe the students are going to change the future of humanity. Currently, there's the scope is enormous scope in the space industry, and maybe soon humans will become interplanetary species. Before that, Vaayusastra want to create a lot of students who is going to change this thing. So yes, thank you so much. See you all soon next week with a new set of
Thank you very much.
topics, with a lot of future scientists. See you
Thank you,
all.
sir.
Bye.
Bye.